Okay, so today we'll be looking at feature selection. All these are built up on what we've done so far. So today we'll be looking at feature selection. Now, in machine learning generally, there's what we call feature selection. Now, what is feature selection? Let me show you an instance. Let's assume this is a data set, right? Now, at times in a data set, there are some features that are very important. For example, now this data set that I gave you, this data set has only, forget about this one. We know this one is the index. So I will remove this. We are dropping this. We have feature 1, feature 2, feature 3, feature 4, and then what we are trying to predict, feature 5, for instance. So we have 5 features in this data set. Now, this data set has limited feature. So this one you can work with everything. And all the data sets we've been working with, their features are not much. So we have always been using them completely. But there are situations whereby you have a data set that has plenty features. For examples, you have like 1,000 columns, 700 columns. They are too much. In fact, if your number of columns are from 20 something, it's too much. And in machine learning or AI general, there's what we call feature reduction. At times, if you didn't reduce your features when you're trying to build a machine learning model, there's tendency of you having an overfitting issue. You might have an overfitting issue. And in last class, I mentioned overfitting. I said overfitting is a situation whereby your machine learning model is developing, it developed very well when you are training it. But when you want to use it to test data, that is when you want to validate it on a real world scenario, it starts giving you an issue. That's what we call overfitting. It's performing well on training data, but performing poor on testing data. Then when we say underfitting is where maybe it's performing well on testing data, but it's performing poorly on training data. That's what we call underfitting. So all these are issues in your machine learning model. A good machine learning model should perform well on training, and it should also perform well in testing. So feature selection is an important concept that as a developer, you always need to use it. As a machine learning expert, you always need to perform feature selection. So feature selection is also another method of data preprocessing. So a lot of things that we've been doing recently, all of them, they are what we call data preprocessing. Remember I told you data preprocessing, as we go, we improve. All these feature selection, feature scaling, handling imbalance, all these things are what we call data preprocessing. All of them are data preprocessing. So feature selection, which we introduced today, is also another data preprocessing technique. So now I'm going to use this simple data set to illustrate what feature selection is. However, always use feature selection if your features are much. But if you have a little data set that has maybe 2, 3, 4, 5 features, at times myself, if the features are 10, at times there's no need. There's no need to perform feature selection, but you can do it. It's up to you. At times you can use all the features, you see the way it's performing, you reduce the feature by perform feature selection, you see the way it's performing, and then you use another one like that, and then compare their performances. So that is the importance of feature selection. Feature selection helps you to reduce the dimensionality of your data. What do I say dimensionality means? Dimensionality means the number of features that you have in your data set. So if I should say reduce the dimension of this data set to 2, what I'm trying to tell you is select only 2 features so that you can use it for model development. That is what we call dimensionality reduction, or we say dimension. You're trying to reduce the size of your features in your data set. So, and I said, why is feature selection important? It's important because it helps you to handle all this overfitting issue, underfitting issue within your data set. So basically, we have different techniques of feature selection. Now, but we have the commonly used ones are 3. We have the filter methods, we have the wrapper methods, and we have the tree-based method. These 3 methods, we are going to look at them properly. Now, some are applied to regression, some are applied to classification. So the filter method, we have 2 types. For regression, we call it Pearson correlation. For classification, we call it chi-square test. Then under the wrapper method, for regression, we call it RFE, using linear or ridge regression, while for classification, we call it RFE on logistic regression. Then the tree-based method, for regression, we usually use decision tree or we use random forest. So that's to tell you, random forest algorithm that we do use is very powerful. It is not just used for model development. You can use it for developing model, and you can also use it for performing feature selection, me, I mostly use random forest for performing my feature selection. Anytime I'm doing feature selection, I usually use random forest. I mostly use it than any other um, method. I mostly use this tree based method and this filter method and this wrapper method. Now, one good thing with what I'm going to do today, already I've provided you with this code. So anytime you want to do feature selection, you don't need to start writing the code afresh. You just copy the code I gave you, you paste it, and then just make change to the number of features, because your target will be on the number of features and the algorithm you use. That's what differentiates majority of the code. So I'll first start looking at how you can use it for regression, and then when we are done with regression, we'll now go to classification. So what do? I imported one of our data set that we'll be using, that shoe size data set. But if you recall, in our first class, we did some feature engineering on the data set, and then we introduced this size HT and then this size status. We did it in our, I think, day 6, in our day 6 file. We did something like that. So it was that data set I brought here and then used. This is the height of people, this is their gender, this is their shoe size. But then I added 2 features, size, height, and then size status. So overall, we have 1, 2, 3, 4, 5. This column is their index. So I'm going to remove it. It's not important. So that is why you see here I dropped it because it's not important. And then this is my data set. You can see we have height, gender, size, this and this. These are our features in our data set. Now, for you to perform feature selection, one thing you need to do first before perform feature selection, after doing your exploration, basically after you've imported your data set, you do exploration. But I skipped exploration because that's not our focus for today's class. If I'll do exploration, it will waste our time. But that's not our focus, and I want us to beat up time. So one of the most important key steps you need to do is data splitting. Now, not splitting into X and Y, not splitting into dependent and into training and data split. No, that is not the splitting I'm talking about. The first split, remember I told you we have 2 types of split. You split into independent and independent, and then after that you go to the next split, which is splitting into training and testing. So the first split you have to perform is splitting your data into dependent and independent. So I dropped the size because in this data set, since that we'll be using it, it is our shoe size that we are always trying to predict. So that is why I dropped our shoe size here in the X. So every other feature, that is this height, this gender, this size HT, and this size status, will be passed as. So we will drop the shoe size so that our Y will be passed as the shoe size. So you check, I splitted the data. This is the training split and this is the testing split, right? So that is the first thing you need to do. Now, after doing that, you will now apply the feature selection technique. Now, the very first feature selection technique we'll be doing is the filter method for regression. And the filter method for regression, we call it Pearson. Sorry, I made a mistake in the spelling, but it's called Pearson. Pearson. Pearson correlation. So that is the first technique. So this is the code for running your Pearson correlation. Now, how does the Pearson correlation work? The Pearson correlation works by checking the correlation of all the features. So if in order for you to run it, you will pass your X variable here, that is your independent variable, and then you say check the correlation with Y variable. So X comes first before Y. So you say, I want you to check the correlation, and then I want you to sort their correlation, that is, arrange their correlation. However, I want the correlation to be in descending order. That is why here I said ascending equal to false. I want you to arrange their correlation, that is, how related are they with the data. If you remember back to one of our class, I said we have 2 types of correlation. We have positive correlation and negative correlation. So this correlation works by checking both the positive and negative correlation of a data and then sort them in order. Which one has a higher correlation, either negative or positive, anyhow. But it checks which one has a higher correlation and then it arranges them. Now, because our data set is small, we have just 5 features. I did something here. I said within our correlation, bring me only the first three correlation. That is, here, this place, this thing you specified here, where I say correlation dot head, this place you specify that I specified 3, that is where you specify the number of features. So if your data set has 20 features and you want to select only 10, instead of putting 3 here, you put 10. So just like I said, for easy usage, this code will always be with you. So anytime you want to perform feature selection, if you're using Pearson, you copy this code and use. If you're using recursive, you copy this code and use. If you're using tree base, you copy this code and use. But I will just highlight the place that you have to make changes to ensure that the number of features you select. So if you are using Pearson correlation, this is the place that you make changes depending on the number of features you want to select. If you want to select 5 features, you change here to 5. If you want to select 4 features, you change here to 4. If you want to select 3, like in my case, you change here to 3. And then you will print the features. Now, why did I print it as a list? Because I want to copy it and use it in my training. When I want to train my data, I want to use it here. So that is why here I said print the list of features that are selected. Now, these are the features that are selected. Top features are the features that are selected, because I said core dot head 3. I said bring me the top 3 features that this correlation here selected, but I said bring me only the top 3. Now, why do I use top features dot keys? I use dot keys because this top features is a dictionary. It brings a dictionary whereby it will tell you the name of the feature selection, and it will also tell the name of the feature selected, and it will give you the correlation of that feature. But I don't need the correlation, I just need the name of the feature, because I'm going to pick it out from my data set. So that is why I say it should bring me only the keys. Remember, a dictionary has what we call key and value. Key on the left hand side, value on the right hand side. So the name of the feature selected is always on the left, while the value of the correlation is always on the right. So that is why I said bring me only the keys. And then I used Plotly to visualize the features, those 3 selected features, so that you can see how important they are. So if I run this code now, you can see these are the 3 features selected. These are my 3 features selected. So once it finished running, you see the visualization. Can you see? These are the features based on their importance. So height is the most important feature. It has a correlation of 0.6814632, followed by gender. The gender is second most highly important feature. It has a correlation of 0.4. Then followed by size status. It has a correlation of 0.41. So these are the 3 most important features that I need. That is to say, if I use this feature to build my machine learning model, my machine learning model will have better performance using these features. So these are my 3 most important features. So how will I use them now in my data set? I will copy them here. I will copy it, I will highlight it, and then press my Ctrl C, and then come down to my next stage, which is feature. I will go back the same thing I did here, where I splitted my data. I will repeat, but this time around, here I used all the features. I only dropped size, but here I'll be specific to my X features. I'll be specific. I will say my X, I want only these features that my algorithm chooses. So how will I do that? I'm going to say X will be equal to, you can say data, and then you put your 2 brackets. No, it's just 1 bracket, because the other one that I copied has another bracket, and then you paste it. So you are being specific. You say my feature, that is my X, should have only these features, and then you add dot values at the end. Why? Because I told you, if you don't have the dot values, it will not be converted to a NumPy array. And then you split your data, you pass your Y also, normal way we've been doing before. Then here next, you split your data into training and testing. So that is why you see here I pass X train, X test, Y train, Y test, and then I pass my train test split the same way we've been doing before. So but the only thing that changed is just the feature selection procedure, and then what you pass as your X. That is the only thing that changes. So you pass it here, and then you do your normal splitting, you pass your test size, and then you run it. Now after running it, you now apply it to your algorithm. You apply it to your algorithm. This is our algorithm. I use a linear regression algorithm. So when I run, you see the algorithm has 81% accuracy based on feature selection. Now, different feature selection technique will give you different features. So you can try different feature selection technique, and then the one that has the highest performance, you can use it. So like this one now, when we did Pearson correlation, it gave us an accuracy of 81%. So let's try other technique and see which one will have better performance. So let me comment this algorithm. I'm no longer using it. So let's go to the second technique. Now, the second technique is called recursive feature elimination. Now, this technique works by eliminating features that are not of importance. That is why it's called recursive feature elimination. It works like a loop. It will go in cycle, and then remove features that are not important. However, the RFE, we call it RFE, or recursive feature elimination technique. This technique work by, in order for you to use this technique, you must give it an estimator. What is an estimator? An estimator is the algorithm that it is going to use to do his selection. That is what we call estimator. But in most cases, we always use linear regression. You can use other algorithm like random forest decision tree, but linear regression is the most commonly used. That is, if you are doing a regression task. If you are doing a classification task, use logistic regression. So if you are using random forest, if you are using for classification, you will say random forest classifier. But if it is regression, you will say random forest regression. But the commonly used one for regression is linear regression, while in classification is logistic regression. Then you give it n features to select. Unlike here the number of features you want to select, you pass it to the head and then you put the feature. Here it has a name. You call it n features to select. That is number of features you want to select. So since I've selected 3 features here, that is why here I maintain 3. So if you are using the recursive feature elimination technique, if you want to change your number of features, this is where you change. If you want 5 features, you change here to 5. If you want 6, you change here to 6. If you want 7, you change here to 7. If it's 10, you put 10. But in my case, it's 3. So your focus will always be here. This is where you make changes. And then you will now pass it to the algorithm. One thing with this technique is it works normal way, like you are trying to train a machine learning algorithm. That is how it works. It works in that similar pattern. So you say the algorithm, that is the RFE algorithm dot fit, and then you pass it your X and your Y, which you splitted here. So I need to go back here and rerun this place. Sorry, excuse me. So I need to go back here and rerun it so that this place will be picked. If not, if I continue using it, it's going to use this X that I splitted here, which is wrong. So that is why I had to rerun this place back. So I will pass the X and the Y here to it, and then for you to see your features, this is how you pass it. You say x.column rfe reg.support. Now this support, it was helps you to get the name of the features. Else, if I didn't pass this support, this is going to bring me only the index of features that are selected. Remember, I told you each feature has an index. For instance, this HT, the index is index 0, gender is index 1, size is index 2. So if you didn't pass this dot support, it's going to bring me their index, which is not what I need. I need their names in order for me to pass it to this my X here and use. So to make things easier, I told you just copy the code I give you and always use it. If not, it will take you a time for you to understand the whole scenario of what is behind this. It takes some time and practice before you can fully understand. But the important thing you need to focus your attention is here, where to change the number of features and then how to pass the algorithm. Now, one thing with a recursive feature elimination is it doesn't use correlation. So that one, you cannot use visualization to see the plot. It will just give you the important features and then it will remove those ones that are less important. So let's run. That is why here you see I didn't put any code like the one we did here for visualizing. I didn't put, because if you visualize, it will bring out all of them with equal length, and I don't need that because it eliminates only features that are not too important and then it leaves those ones that are important. So let's run it. Now you can see this one selected these 3 features. I think the features selected are the same with the one that the former algorithm selected. Okay, no, they are different. This one selected height, gender, and size. This one selected height, shoe size, height, and then size status. Recall, the performance is 81%, right? So let's run this and then let's apply it. I'm skipping here because I'm coming back here to do another explanation. Now you can see the second technique has better performance. Look, our algorithm has 94%. So you agree with me that this technique In this scenario, there are some scenario that this first one will perform better. But in this scenario, so far, this second technique, this RFE technique of feature selection have better performance than this one. This one produced 81% accuracy. This one produced 94% accuracy. So RFE was better than Pearson correlation. Now let's go to tree base, that is how to use random forest, and then let's see whether random forest will be able to outperform those other two. So if it is random forest, first thing is you pass your random forest algorithm. Since it's regression we are doing, is a regression task. That is why I say I pass random forest regressor. If it is a classification task, I'll say random forest classifier. And then I say dot fit. You pass your data that you want to test. That is the data you want to perform the feature selection from. Remember, I need to go back here and rerun here again so that this X will re-update itself. So I want to select features from here, but you want to compare it. You want to check their relationship with this Y variable. So that is why you need to fit it both on X and Y. The same way you are developing an algorithm where you fit on X trade and Y trade is the same way. And then the selected features here, you will say I want it to sort the feature. I sorted the feature here. And then this code continues here. This is a continuation of the code. Sorted values in ascending order, and then dot head. The same way here we selected the dot head, we sorted it, and then we selected the top 3. Here too, you sort it that way, and then you select. This is where you specify the number of features you want to select. So if it is 10 features, you change this 3 to 10. If it is 3 features, you change it to 3. If it is 13, any number of your features. But in our case, we are selecting just 3. So I pass it to 3. So this one too also brings a dictionary. That is why here you see I say print a list of selected features dot keys, because I want to see the names of the features selected. And then unlike the recursive, this one doesn't allow visualization because it will bring all the bars with equal length. This one works like the correlation. So it will allow you to see the features and their level of importance. So if I should run it, we'll see the features. So you can see this one selected the same features that Pearson correlation selected, but that's not always the case. At times they will select different features for you. I think, okay, it's not even the same features. It's not the same features. So you can see this one, its correlation is 0.6. This one, the correlation is 0.2. This one, the correlation is 0.09. So that is what random forest saw as the most important features. So let's try it. So we need to change here and pass those features. I've changed it. So let's run it, and then let's go and build our model. Let's see the performance. Now you can see this one had better performance. So this random forest. So if I'm trying to choose a method now, based on what I've done for this regression task, if I'm trying to choose a method now for my feature selection, I'm going to go with this random forest. But normally, random forest to me has always been the best method for feature selection because it has better performance than other ones. That's the one I usually use whenever I'm trying to perform feature selection. So mind you, I said this in the whole code, this should be your focus, where to change your number of features. So if I should say build a model and then I say select 10 features, or at times up to you. The number of features you select depends on you. So you can be trying different features. You can select 5, run it, see the performance, take note of it, come back, change it, select 7, run it, see the performance, take note of it, come back, select 10, run it, see the performance, like that, until you get the best performing algorithm. Because that's how machine learning model works. It is not just once that you get the best performing model. You need to test them and test run them several times before you can be able to come up with the final decision. So machine learning is not all about running your model once. So far, the reason why all your assignment and everything have allowed you to run it once is because we are still practicing. But if you are trying to build a real world scenario, a machine learning algorithm, you don't run it once. You can take days running it. And one thing with them is the more you run them, the better they become. So you can take a month running your machine learning model. You can take a week, you can take 2 weeks. Keep running it, keep trying different parameters until you get the best performing one, and then you conclude. So that is how it works. So far, these are the techniques for performing feature selection on regression. These are the techniques. So back to what I did here, there's a table I did here. Now, if you recall in our last class, I introduced feature scaling when I told you use the standard scaler. But there was something I didn't tell you. Now, you may ask yourself, is it every time you have to use standard scaler on your data? No, it is not every time. You using standard scalar, there are some algorithm that they don't need it. Algorithm like ensemble algorithms like random forest, decision tree, SGBoost, naive bias. These algorithms don't need random forest. The only algorithm they don't need standardizing. You don't need to scale them. The data that algorithm that needs scaling are those algorithms that they usually use line. They use line or they are in form of neurons. Those are the algorithms that you must scale them. If you didn't scale them, like this linear algorithm now, if I should scale this data, let me show you something. Let me go back to the first technique. Let me go back to this first technique. I want to show you something. Oops, it will raise an error. I didn't rerun this here. So let's rerun this. Now let's rerun this. Okay. Now these are the features selected. Now, when we ran it that first time, I think it gave us an accuracy of 81%, if I'm not mistaken. It gave us an accuracy of 81%. Now, let me pass it here back. Let's run it. Or let me first skip that step. Let's rerun. Now, it's even giving a very wrong algorithm. Now, let me scale it. Come. I think there's an issue somewhere. Let me restart the kernel. Okay. Let it run to this stage. I want to show you the impact that feature selection we did has on the data. Okay, let's first of all run into that. Okay, now you can see now the performance is even very poor. When I run it without feature selection, it's showing me 0.17. Now, without feature scaling, now let's scale the data. And then let's run it. It's still showing the same thing. I'm coming. Let me use a different technique since this first one is not giving me what I really want. I want to see a change on the performance. Let me use the second one. Now, but the thing is, normally in all these linear algorithms, as I was saying, if you use feature scaling on them, feature scaling usually helps to improve their performance. It usually helps to improve their performance. I think the kernel wants me to restart it again severally, but it will waste our time. So that's why I just want to continue because I'm trying to show you feature selection is our scope for today, but I just want to show a little. Okay, now this one has 96% accuracy. Huh? Now let's scale it and see what we have. Okay, they are all giving the same result, but basically feature scale, ideally the performance is supposed to improve. It's supposed to improve. I want to believe the reason has to do it because I selected little number of features. Because since this is a small data set, but the important thing you should know is whenever you perform feature scaling, definitely you see a change. If I should use a data set that has more features, maybe it has 10 and then maybe I use 9, then I use this feature scaling, definitely this performance, there will be an improvement. Your performance will not reduce. It will hardly reduce. That is why you see even this case, although it didn't improve, but it remains stagnant. So it can't go lower than the performance it was having when I didn't use feature scaling. So feature scaling helps to improve your performance. So when are you to apply feature scaling? You have to apply feature scaling when you have algorithms that uses line. So algorithms like linear regression, logistic regression, support vector machine, k-nearest neighbor, and neural networks. All these algorithms, before you use them, you must scale them first. So please always take note of that. If you are trying to build, if I say build a model and you are trying to use any of this algorithm to build, please always scale. Don't jump this step. Always do this step before you come to this step. However, if it is a decision tree or a random forest or any other ensemble algorithm you are doing, this step is not important. You can jump it and then go straight after you've splitted your data, you've done your feature selection, go straight to build your model here. There is no problem. It won't cause any problem for you. So that is the significance of feature scaling. So only scale your data when your algorithm is using a line. If your algorithm is not an algorithm that is using a straight line, if it is a tree-based algorithm, or naive bias, always use it without performing feature scaling. So that's the difference between the technique. So for the classification, I picked a data set, that heart disease data set that we worked with in one of our classes was the same data set I used here. Now today I didn't run my code in Google Colab. I decided to use my VS Code. I run it on my local machine. So this was the data set, if you recall. This was the data set. There's no class imbalance issue. So I splitted my data using the second splitting technique I taught you. I splitted into X and Y. Now, the first filter method, I told you in regression, in classification, it is not called Pearson correlation. It is in regression that is called Pearson. In classification, we call it chi-square test. So that's the first technique I'll be looking at. I'll perform the chi-square test. Now, in the chi-square test, we use an algorithm called select k-best. We use an algorithm called select k-best. So first thing first, you need to pass that algorithm, select k-best, because that's the algorithm that will check. It will select the best number of k. K means the best number of features. Now, this my data set. If you check, this one has 13 features, although 12 are independent, one is dependent, right? So I will say I have 12 features to make selection from. So in this my feature selection, I decided to select the best 5. So what is this K? I said K stands for the number of best features that you want. So the select K best technique is a technique that selects your number of Ks for you, that is the number of features, the one that he sees as the best feature for you to use in your model development. So you always pass it a score function called chi. That is why it is called chi-square. It is called chi-square, or you say chi-square. It is called chi-square method. Why is it called chi-square method? Because in the score function, you always pass that chi-square, because the chi-square is the one that is the algorithm that is going to work on the features and select, the same way Pearson correlation uses their correlation to select the features that are very, very correlated to the data. That is what the chi-square does here too. The other one, we say correlate with, and then to check how correlated they are. This one, it is this chi-square now that will check the relationship among the variables. It will check the relationship among them and then brings out the one that is very, very more, that is highly important to the variable that you are trying to predict. So that is what differentiates this one and the other technique. That is the Pearson correlation technique. All right. So if you pass it here and then here, unlike Pearson correlation, it is in the head that you change the number of features that you want to select. Here, it is in this K that you change the number of features. But mind you, in this case, there are 2 places you will change, here and here. If you change your number of features here, you must reflect it here, because this place, this is what will help you to arrange the features based on how important they are. Here we select the features based on importance, but it will not arrange them. This algorithm, this code that I wrote here is what will help you to arrange them. That is why I say sort values ascending order equal to false dot head 5. That is, I want you to bring out the first 5 most important. So if you pass the number of features here that you want you to select, you must pass it here also to be specific that I want you to bring out these top features for me. So I said I want to select 5. That is why here I put 5. So if I change here to 7, I must come back here, change here to 7 also, so that there won't be conflict in my selection. So I will return it back to 5, and then you fit it the same way, the way you are training a machine learning algorithm. You always fit. After you select the features, you fit it on your X train, on your X data and your Y data. That is your dependent and independent variable. And then for you to see the features, this print list score.keys is what helps you to see the features that have been selected. Then here I'll just visualize those top features. So if I should run it, you can see these are the features that is selected. So same way we did earlier, I'll just copy these features and then go to where I'll split my data into training and testing, and then I pass it here again. I pass it here and then I split my data in the last line. So let me change here maybe to 0.2 because this one is a higher data set. So since I'm using a logistic regression, let me just scale my data and then I train my model. Now you can see it has an accuracy score of 76% accuracy when I used this technique, this first technique for performing feature selection. So let's try another technique. Let's try the second technique, the RFE technique. Remember, I told you the RFE technique is the same with the one we did in regression. The only difference is here we need to give it a classification algorithm. So logistic regression is a classification algorithm. So I fit it also, and then I pass the number of this is where I pass the number of features. I want it to select just 5 features for me. So let's run it and see those 5 features selected. Okay, sorry, I didn't run. I forgot to run this place back it's because I'm showing you different techniques, so I have to run it back. After I've gotten to the end, I'll need to rerun it back again. So on your own, if you are doing it, you can decide to use individual techniques so as to avoid that running. Okay, these are the features selected. It's giving me a warning because probably there's an update in the algorithm. There's an update in this how to use this algorithm. That's why it's bringing out this one. But this is the feature selected. Let me do something. Oh, sorry. I don't want that warning to show up. That's why I cancelled it here. Okay, so these are the features selected. So I'll pick it and then I pass it to this my algorithm. Now, mind you, when we ran it the other time, it gave us a performance score of 76%, right? So now let's run it and see what the performance will be. So since we've passed it here, we ran it. Let's scale the data. Now this one gave us 70%. That's to tell you that the former technique, that is the select k-best technique, performed better in this scenario than RFE score. So if I'm trying to make selection among these two now, if I'm trying to build a model and I'm trying to make selection, I'm going to use this first technique because it has better performance. So let's try the third one and see whether it will be better or it will be less. So this one too is the same way we did it in the regression task. Just that here, if we are trying to pass the algorithm, we pass random forest classifier instead of random forest regressor. We are going to pass, sorry, a minute. So we are going to pass random forest classifier instead of the normal random forest regressor that we passed here. You can see here it was random forest regressor. Why? Because we are doing a regression task. So here we are not going to use random forest regressor, rather we are going to say random forest classifier. So that's just what differentiated the technique here and the one in the previous technique. And mind you, Here we specify the number of features. So you can see in this second example, all my features were 5. So that is why everywhere I've been putting 5 as my number of features. So let's run it and let's see the features it selected. Okay, these were the features it selected. Among those 12 features, these were the 5 top features it selected. So let's pass it here and then run it. Now you can see this one gives 74%. This one gives 74% as our accuracy. Okay. This one gives 74% as our accuracy. So among those 3 techniques, you can see random forest gives 74, RFE gave 70, and then chi square, or you say select k-best technique, gave 76. So if you are trying to use a particular technique now based on this feature selection technique we did, we are going to choose this first one. Why? Because it gave the optimum performance. So whenever you are trying to build a machine learning algorithm, this same thing I did, the similar thing you do, you test them, you test the first technique, or you can create separate notebooks. That is separate Jupyter file. This first Jupyter file use this technique. This second Jupyter file use this technique. So you just duplicate your code and then just make those changes and then try them. And then after that, you compare all of them and see the one that has the better performance is the one that you pick and use. Then the one that has lesser performance, you can discard it. So that is how we perform feature selection. So feature selection is very important because it helps reduce the dimensionality of your data. So once it reduces the dimensionality, it will help handle any form of overfitting or underfitting issue for you within your data set. So just like I told you, I know the code looks somehow cumbersome, scary. That is why I said for practice sake, always copy the code and put. Always copy the code and put. Because even me at times, if I'm trying to build a machine learning model, if I'm trying to do a work, I don't usually start typing the code afresh. Normally, I'm just giving the secret to all these things. The moment you understand some of these things, you don't need to always write your code afresh, except if you are trying to practice and see how well you've gone. But if you've understood some of this logic, you don't need to start typing the code afresh. You can copy, it's your code. You can copy it, paste it, and then just do little editing on the code, make the necessary changes, and then run. It will save you much time. So I've shared you this file, so you can always copy the code. If you want to apply the chi-square or the select k-best technique, you can copy this code, you put. However, take note, always make changes to your number of features depending on the features you want to select and work with. So I think that is what I have for you us today. Just these are feature selection techniques, how to use it in classification, and also how to use it in regression tags. So I think with that, I've come to the end of what I have for today. So I don't know, I'll give room for questions before we call it a wrap. Is there any question on what we've done so far? Any question? Okay.
Yeah, actually, I have a question though.
Okay.
Sorry, I don't know. Today, my network has really not been networking at all. Honestly, my network was really bad today.
All right.
So sometimes the thing will just skip and I'll just go off and I'll be struggling to come back on again.
Okay.
So I don't know. Sha, today's class, I don't know if it's still from my network. The class today is like I saved the speed is X2. I don't know if it's only me, Sha. I don't know. Actually, we're trying to meet up with the time, Sha, but at some point I will still understand the Sha. So
Okay.
my question actually, but I don't
Yeah.
know. In between, the network was really bad. I couldn't come online, so I don't know. I want to ask, why creating a model about this regression and classification? Like, when are we to use them? Is there actually a time we're meant to use this one or this one, or do you have to try this one and try this one, then pick one out of it? Or are we to do the two of them inside the modeling, like both
I don't
the
understand.
regression and
To
classification?
do okay, to do both regression and classification the same work.
Yes, like I'm
Mm,
asking, like, are we supposed to do it both of them, or is there a time where we need to choose one particular one to use?
so your data once you are given a data, from the data you know whether you have to do a regression for you to do a classification. That was why, right from day one, I differentiated something. I said, okay, let's assume a company wants to give you work. And then they said,
Yeah.
we are, okay, let me give a practical example. Pampe. Pampe
Okay.
approached you and said, we want you to build a machine learning model for us. We want to be giving
Mm.
people loan, but we discovered that whenever we are giving people loan, some of them don't usually pay back.
Payback.
We want you
Okay.
to build a machine learning model that will predict whether somebody will pay back his loan when we give him or he will not. From this statement,
Okay.
from this scenario, what type of analysis does this scenario looks like? Does it look like a regression analysis or a classification?
My classification.
Good. So you already know what you have to do.
Okay.
Why?
Okay.
Because we said they want you to build a model that will predict whether the person will return the loan
The
or
return.
not. They
Yeah.
gave you just two options.
Okay.
That
Okay.
is
Okay. Okay.
classification.
Okay.
Anything that has to do
Yeah.
with categorizing something, category. Remember, I told you classification, we have more than, at times, it's not just A and B. We have what we call multi-class. That's what we
Okay.
do in our next class, where you have more than two classes.
Mm.
However, as long as it is category, we are predicting. As long as it is category, it's classification.
Yeah.
You understand?
Okay.
Okay, another scenario.
Okay.
Let's say NEPA. You are working with a power with an electric station, and then they told you that this power plant is producing different energy values. Power energy. Maybe today it produced 9,000 watts, tomorrow it generated 4,000 watts. We said, okay, we want you to build a model that we can predict, okay, maybe if we put this amount of energy to it, is going to produce a particular amount of energy at the end of the day. Those
Mm.
kind of situations, since it's something that has to do with energy, energy is a continuous value. 2,000 watt, 3,000 watt, it is not a category, it is a continuous value. So if a company wants you to build a model like that, or I said I want you to build a model that can predict house price, these are continuous values. Automatically, you know that is
Oh,
regression.
regression.
You
Yes.
understand? So that is what differentiates.
Yeah.
As long as it's
Oh,
something that has to do with
okay.
category, classification. If it is something that has to do with you predicting money, value, quantity, those
Values.
ones is
Yeah.
regression.
Science. Okay.
So it's clever.
Okay. Okay.